Hello students, we are going to see another JEE Mains question here. The question is, in order to determine the Young's modulus of a wire of radius this and length this, a weight of mass 1 kg was hanged to get the elongation 0.5 centimeter. We have to find the fractional error in the value of the Young's modulus determined by this experiment. Option is given in percentage, so we'll be calculating the percentage error. So what is given? The mass is given, so force on this string will be mg. If you're hanging mass mg with the help of a thread, then the force or tension in the wire, it will be mg. So stress will be F upon area, that will be equal to Young's modulus into the extension divided by the length. If you want to write it in terms of Young's modulus, this will be FL by AE. Now, area is not given, but radius is given. So I'll modify this equation as FL by pi r square, and instead of F, I can write mg. So the fractional error can be written as delta y by y equals delta m by m plus delta L by L plus twice of delta R by R plus delta E by E. Now, the pi and the g, these two are constants, so we'll not include them in error. So the percentage error will be delta y by pi into 100%. We calculate this and multiply it by 100%. So delta m, mass is measured with a least count of 1 gram, that is 0.001 kg divided by 1 kg, plus delta L, that is error in the length. So it is measured using a least count of 1 millimeter. It will be 0.001 divided by 1 meter plus twice of error in radius measurement, that is 0.2 centimeter, and error is 0.001. So twice of 0.001 by 0.2, and error in extension, that is 0.001 centimeter divided by the extension that has the same unit, centimeter, whole thing multiplied by 100%. If we calculate this, we'll be getting 100 multiplied by every number here inside. So this will be 0.1. This will be again 0.1. Here it will be 0.1 by 0.2, that is 1 by 2, 0.5 multiplied by 2, that is 1. And this will be 0.1 by 0.5, that is 1 by 5, so 0.2. The answer here will be 1.4%. Another question from error. Radius of the sphere is measured and we have to find the percentage error in the volume. So formula for volume is 4 by 3 pi r cube. 4 by 3 and pi r are constant. So we can write the fractional error as delta v by v, as the power of r is 3. So 3 delta r by r. To find the percentage error, I have to multiply this quantity by 100, and this will give me 3 times delta r by r into 100%. So delta r, error in radius, is 0.85 and the radius is 7.50 into the 100%. So this is 3 times 85 divided by 7.5, that is 75 by 10. You can do some calculation. 325, 75, 5 to 10, 5, 5. This will go 17 times, and the answer would be 34%. 34% is the answer for this. This was an NIT type question, numerical answer type. So here you'll be writing 34 is the percentage error. Here there is a question. We have to find dimensions of lambda. C is the capacitance, V is the voltage, and lambda is C by V. If lambda is written as C by V, then we also know that C is equal to Q upon V, the voltage. So to put it here, we'll get this as Q over V square. Now, if you want to write the voltages, dimensions of voltage or unit is joules per coulomb. Unit is joules per coulomb. So for charge, if you write the units for charge, it will be coulomb divided by joules per coulomb whole thing squared. So this will become coulomb cube per joule square. And to write the dimensions of coulomb is current into time. So I cube into T cube. And joules is the unit of energy. So kinetic energy is mv square, ml square, T minus 2, this whole thing squared. So this will give me m squared, it will go above, so m minus 2, L squared, then it goes above, so L minus 4, then I cube, that is I cube, T raised to minus 4, and T cube, that they will add up to give you T raised to 7. So M raised to minus 2, L raised to minus 4, I raised to 3, T raised to 7. That is second option. Second option is correct. In this question, E is the electronic charge, C is the speed of light in free space, H is the Planck's constant, and the quantity this has dimensions of, that's the question. So if I see E square by 4 pi epsilon naught, I can relate it with the force. Force is E square by 4 pi epsilon naught into R square. So E square by 4 pi epsilon naught, that is the force between two electrons, can be written as force times R square. If I want to write the unit of this quantity, it will be Newton into meter square. And then Hc, I know that energy is Hc by lambda. Energy is Hc by lambda. So if I want to write the unit of this Hc, it will be unit of energy into unit of lambda. So unit of this quantity will be joules into meter. So joules into meter, that will be equal to, joules is Newton into meter, work done is force into displacement. So joules is Newton into meter. So this becomes Newton into meter squared. So this quantity 1 by 4 pi epsilon naught E square by Hc, this will have units of Newton meter square, that is E square by 4 pi epsilon naught unit divided by unit of Hc, that is Newton into meter square. So that is, it has no units. So we can write the dimensions as m raised to 0, L raised to 0, T raised to 0. All the units are getting cancelled out. So this is a dimensionless quantity.